Can you believe we only have 2 more Karel programs left to write together? I know, it's sad. I'm sad, you're sad, but soon enough we're gonna have to move on from Karel into bigger and better things. But not today. Today we're gonna be looking at a Karel problem that I think is actually one of the cooler ones. It might not look as flashy as some of the other ones, but we're gonna do some actually pretty interesting problem solving here. Let me actually show you what we're gonna make Karel do, because I want you to think about how we're gonna make her do it. It's gonna be some interesting problem solving going on. I've opened up a version that actually is completed. So the code in here actually works and all of these are filled out. Now yours won't do this when you run it right now. We're gonna have to write this together, but I do wanna show you what's gonna happen here. You might not have known this about Karel, but Karel's actually a math whiz. Specifically, Karel's really good at multiplying by 2. You see this pile of beepers that actually is 5 beepers stacked on top of each other here? Look at what Karel's gonna do right now. Oh my gosh, now there's 10 beepers on that pile. And let's see if I run this again, what's gonna happen now? Oh my goodness, now there's 20. Let's run it again. 40, 80, 160. And you can almost see a little bit of Karel doing something as we make that number bigger and bigger. Now, there's a reason I made this super fast, and that's that I don't actually want you to see straight up what's going on with this. I want you to pause this video and try to think to yourself, how could Karel possibly do this? And some things that might help you here. Karel's only using the things on this sheet. So maybe there's some control structures being used. There's definitely some sensory conditions being used. And these are my 4 standard Karel methods. Those are definitely being used. Another thing is that Karel actually starts with infinite beepers in their beeper bag. So it's not like if I pick one up, I can say how many beepers are in the bag and then put kind of double that down, if that makes sense. So take a second, pause this, and try to think about how Karel might be doing this. All right, hopefully you've thought a little bit, and it's totally fine if you haven't come up with a great solution, but really what's happening here, let me play this kind of slowly for you, is Karel goes to the stack, picks up 1 beeper, and for every 1 beeper Karel's picking up, she actually has an intermediate stack over here where they're putting down 2 beepers. And then what does Karel have to do once that's done? Well, of course, move every individual beeper back over to the original stack. And then Karel's eventually going to end up back in their original position at 1, 1, like nothing ever happened and there was only ever 1 pile left. So this is what we're going to make Karel do. And I'm going to keep up this completed version just so we can kind of see what's going on, but that's going to be the general picture. And are we going to use decomposition and top-down design? Of course we are. So let's go ahead and let's open up the DoubleBeepers program. And again, just to keep this open, let's do that. So how do I actually double the pile of beepers? Well, we're going to move to get on top of it. Then we're going to double the beepers in the stack, which, wow, that seems like that method's going to be a little bit involved. It will be. Then we're going to move back. And now this move back isn't just a move because it's going to be actually slightly more complicated than that. What Karel's going to have to do is we're assuming this move back happens when they're actually kind of facing the wrong way. So let's say Karel's here and facing this way. Karel's going to have to fully turn around, like do a 180, move 1 spot this way, and then turn themselves back around. So let's actually code that move back method first, because it's actually fairly straightforward. Karel's going to turn around. We're going to have to code that. That's super easy. Then move, then turn around, just like I just said. Now, turn around is not one of those base Karel methods. It's kind of like a turn right. How do I turn around is I just turn left twice. So let's do public void turn around. And here I'm just going to have turn left, turn left. Okay, So sweet, it seems like we've done half. We really haven't. We have this big method to tackle, which is double beepers in stack. So let's do public void double beepers in stack. And now how do we double the beepers in the stack? Well, first we have to make stack twice as big next door. And again, you're looking at me like, oh my gosh, this is ridiculous, but we're just practicing. And since I'm the one making this video and you're the one watching it, you're just gonna do what I'm doing. Once we've made that stack twice as big next door, then we have to move the pile back. Sweet. Again, we're just continually breaking this down. Public void make stack twice, oh gosh, I can't spell, twice as big next door. How do I make a stack twice as big next door? Well, kind of like what Karel was doing, I'm gonna pick one up here, move over here, put two down, and then I'm gonna move back. And I'm gonna do that while there's still beepers in my original stack. So let's do this. While beepers present, let's put 2 beepers in other stack, and then let's move back. Now it's feeling really handy that I have that move back method. Actually, before I put 2 beepers in the other stack, I actually have to pick up the beeper from the original stack. So I think I'm missing a pick beeper here. I pick up one, I put 2 over here, and then I move myself back. Sweet. Now let's write this method, this super complicated method, public void put 2 beepers in other stack, which I think is just going to be a move, put beeper, oops, put beeper. Okay, I think we've successfully done make stack twice as big next door. Now we just have to deal with move pile back. Public void move pile back. And now we know that at the end of making the stack twice as big next door, I'll be standing on spot number 2. So what's the process to move all of these back here? Don't I need to kind of move over, pick one up, move back, put it down? But in order to make this while loop first, I think I need to start by moving, because when do I know that I'm done is when I run out of beepers here. So I actually want to start on this stack. So let's first start with a move. Now I'm on top of where the doubled stack will be here. Then I can do a while beepers present. I can pick beeper, move back, and put beeper, and then move. So I'm picking up a beeper here, moving back here, putting it down, moving back over. This will end me up on spot number 3. Now this isn't exactly what I want. Remember, Karel actually ended up kind of back over here. So I do think that at the very beginning, I actually need an extra move back at the end here, because I'm going to be at 3, not at 2. Now we've coded a lot of this without actually checking any of it. Let's go ahead and see if this works. I'm going to go pretty slow. All right, looks like doubling is working. We're making our stack next door. Okay, this seems to be working. Karel's moving them back, moving them back. Karel's a little slow for my liking, but I did that on purpose, so it's fine. Go, Karel, go. And Karel's done it. There we go. We've doubled the beepers on the stack. And if you want this to be super satisfying, let's make it fast. We can keep spamming this. How high can you get it? And as you start to get a lot higher, you can kind of see Karel doing this motion where they're moving the beepers back and forth between the two piles. You actually can make this number pretty dang big. But you know that every time you run this, there's a whole hell of a lot going on in terms of Karel doing things, which means that every single time the number gets bigger, it's going to take longer. And eventually you'll get up to a number that Karel really just can't finish in a feasible amount of time, and you'll kind of be stuck. Even this one's a little big. Let's see what number this ends up with. I'm about 2 million right now. You can definitely get it up higher than that, but that's pretty good. Remember when we started off at the very beginning of Karel, we were just kind of picking up a TV remote and putting it back on a table? It's actually really cool that in just a couple of days, we've managed to make this a whole lot crazier. Karel can do some pretty intense problem solving with really just a few methods. We're going to see a program next time that is a little bit similar. It's a little bit kind of mathy, using some Karel things to do this interesting problem that you wouldn't have thought Karel could actually do. It's going to be pretty cool.